Hello, my name is Sriram. Roll number is 24951A6747. I am from CSC Data Science Department, and this course title is Discrete Mathematical Structures. Course code is ACD-T01. Topic title is Modeling Users' Interactions in Social Networks. Modeling user interactions in social networks, binary relations, compatibility, and equivalence classes. Why model user interactions mathematically? Social networks are complex webs of connections that extend far beyond simple friendships. Understanding interaction patterns helps predict behavior, recommend connections, and analyze influence across platforms. Binary relations provide a foundational, precise mathematical framework to represent who interacts with whom, transforming messy social data into analyzable structures. What are binary relations in social networks? Definition: a binary relation is a set of ordered pairs. Example for user A and user B. It indicates indicating a specific interaction or connection between users. Here, the common examples are relations, which includes followers, likes, messages, trusts, or shares content with across various platforms. Direction matters. These relations can be directed, like A to B, or undirected, capturing asymmetric or symmetric interactions. Visualizing binary relations. The interaction graph. First one is nodes represents users. Each individual in the network is a vertex in the graph structure. Second one, edges represent binary relations. Directed edges show asymmetric interactions like A follows B, but B may not follow A. Binary edge adjacency matrix. Edge presence equal 1, absence equal 0, creating a mathematical representation. Compatibility of users. When are two users compatible? Compatibility means users share similar interaction patterns or relational properties within the network. Two users are formally compatible if their binary relations satisfy certain conditions, such as mutual following or shared friend connections. This concept helps cluster users with similar social roles, behaviors, or influence patterns, enabling more nuanced network analysis. Equivalence classes, grouping users by interaction patterns. First step, reflexive reflexive property. Every user is related to themselves under the equivalence relation. Second step, symmetric property. If user A is related to user B, then user B is related to user A. Transitive property. Step 3 is transitive property. If A relates to B and B relates to C, then A relates to C too. Users grouped into equivalence classes share indistinguishable interaction profiles under the relation. For example, users mutually connected by friendship naturally form an equivalence class, revealing tight-knit communities. From theory to practice. Example in social networks. Twitter mutual followers. Users who follow each other form equivalence classes, indicating close communities and shared interests within the platform. Facebook friendship. Friendship is a symmetric equivalence relation where groups of friends form natural equivalence classes representing social circles. Trust networks. Compatibility extends to similarity in content interaction patterns or trust relationships across professional networks. And this is applicable to other social networks too: Twitter, Threads, Facebook, LinkedIn, Instagram, YouTube, and etc. Why are these concepts powerful? Simplify complexity. Group users into meaningful clusters, reducing network complexity while preserving essential structure. Enable smart smart algorithms, forefront recommendations, community detection, and influence analysis with mathematical precision. Rigorous analysis. Provide a formal framework to analyze social dynamics beyond intuition and guesswork. Challenges and extensions. Multiple networks. Real world interactions are multiplex. Multiple types of relations coexist simultaneously, such as likes, comments, shares, and direct messages across different contexts. Weighted relations. Binary relations can be extended to weighted or multi-valued relations for richer, more nuanced modeling of interaction strength and frequency. Enhanced compatibility. Compatibility criteria can incorporate user attributes, content similarity, temporal dynamics, and contextual information for deeper insights. Harnessing binary relations to decode social networks. Modeling users' interaction as binary relation reveals hidden structures and patterns with complex social ecosystems. Compatibility and equivalence classes help us understand social cohesion, segmentation, and community formation. These mathematical tools empower better design and analysis of social platforms, fostering more meaningful connections and unlocking deeper insights into social behavior.